everyone, and welcome back to my channel. So I wanted to create a series where I want to discuss different technical skills that I've been working on, and I figured it might help someone out who is in the same boat as me, just trying to learn different technical skills, and it might offer them an easier and better explanation. So today I will be discussing the higher and lower level services of the Amazon Solution Architect exam. So this is just a brief overview of the AWS services that are tested on the Solution Architect Associate exam. Keep in mind this is just for that particular exam and not for the developer's exam or anything else. This is just a brief overview, and without further ado, let's get started. So let's start off with a basic overview on how AWS is structured. So before I delve into more details about the services, I want to give a basic overview to somebody who is new to this subject, and like me, I didn't really understand it at first either, but as I read more about it, I want to delve into the details of each service in later videos, and in this one it's just sort of a brief overview. So the first service I wanted to talk about is the global infrastructure. So the global infrastructure in AWS is essentially the basic building block of the AWS architecture. It's essentially where all of the AWS services are based. You have different regions such as US, Europe, Canada, where you can use the AWS services, and this comprises of the global infrastructure. And it's on top of this service that the other services such as compute, storage, and databases are built on. So this is layer one. So on top of this global infrastructure, you have AWS compute services. So AWS compute services basically allow you to develop, deploy, and test applications on the server. So every time you think of compute services in AWS, I want you to think of being able to reserve portions of the AWS cloud, which is essentially what it is. Compute services allows you to essentially develop your application on a server, run it, test it, deploy it, etc. So AWS essentially offers you a portion of their cloud at a price or in free tier, where you can test, deploy, and run applications. So some examples of these services are EC2 and Lambda, which I will be discussing in later videos in depth. So next we have our storage services, where you can store, access, govern, and analyze your data at a reduced cost. So basically, Amazon allows you to store your files, objects, and other associated data on the cloud, and you can even reserve certain portions of the cloud as blocks and save them as block storage. Of course, all of this comes at a cost that's decided by Amazon. So some examples of storage services are S3, or Simple Storage Service, where basically you store files that you have from your computer in S3 buckets. So I just want you to think of S3 buckets as like a container where you can sort of store and upload files and share them with other Amazon users with their own Amazon accounts, and EFS. So on top of that, we have, or next to it actually, we have database services, which could be relational database services like RDS, or non-relational database services like DynamoDB. So quick overview of like what relational databases are versus non-relational databases. So for relational databases, they are essentially able to form a relationship between table A and table B. So how's that? Let's give an example. Let's say that we have a university and a bunch of students go to that university, and we have all the details of a particular student stored in a student table. Contains their student ID, contains their address, contains their phone number. Now in another table, we have student grades, which just contains their ID and their grades. So we want to make sure that we have one report which has the students' address details, their phone number, along with their grades. We want to send the report cards home to their parents or whatever, but we also want to include all of their details and make sure that the right grades are getting sent to the right student's address. So how are we going to do that? Well, we do have one column, which is the student ID, which is common in both of those tables. So we can form a relationship based off of the student ID column, and we can join the two tables to create one comprehensive report. Now, in a non-relational database, basically, it's sort of like a dictionary. That is, it's just a key value pair. So you have an identifier, and then you have different objects that are associated to that identifier. Now, you might ask, what's the need of having a non-relational database when you already have a relational database, which works much better because you can actually form a relationship between the two tables, whereas in a non-relational database, if you have one dictionary that might have the same identifier as another dictionary, there's no relationship between those two things. So before, back when computers were, huge and not as small as they are now, storage was extremely expensive. So to save on storage, relational databases were essentially created where you needed a relationship between two tables to retrieve data. But now storage is cheap as hell. Oh shit, I'm gonna get demonetized. Okay, storage is incredibly cheap, and we have to focus more on compute time. So to focus more on compute time, it's much easier and much faster to retrieve objects via an identifier. So non-relational databases are much more easier on the compute time, whereas relational databases help you to save on storage, but they take a much longer time to retrieve data. So that's just non-relational databases are just much more efficient. So that's it for this video, guys. I just wanted to create a short sort of watchable video for anybody who might be interested in AWS services. I will be creating a part 2 to this video so that we can discuss more services, an overview, and then talk about it more in depth. I will be uploading a little bit better on this channel. I know I've been sort of on and off on this, but I will try to finish part 2 within this week. Thanks so much for watching, not only this video and all of my previous videos, and if you like this video, please like it and subscribe to my channel. Thanks so much. Bye! Thank you.